Global subsea drilling operations could not take place without a safety-critical blowout preventer, or BOP. Traditionally, BOPs are controlled and monitored using a MUX system, which relies on an umbilical connection to the drilling vessel. Umbilicals are deployed from topside reelers through the moon pool and attached to the riser by an operator as the riser is run out. Attaching the umbilical to the riser is a dangerous operation, and the reelers add both cost and deck space overheads to the MUX system. To improve safety, cut cost, reduce deck usage, and negate the issue of riser recovery owing to umbilical damage, Cameron and Nautronix see the application of acoustics as the future of BOP control and have developed Nasmux, the world's first acoustic MUX for BOPs. Nasmux utilizes existing MUX equipment both topside and subsea, using acoustics to provide communication between them. Let's look at this in more depth. Topside, the tool pusher and driller's panels are located in their traditional positions on the rig. Additional remote emergency disconnect buttons are strategically placed. These all feed into the MUX. However, instead of traditional reels and umbilicals, the MUX is connected to Nasmux topside equipment. This comprises a surface processing unit, power amplifier, and acoustic transducers. Subsea, the existing MUX components of blue and yellow pods remain. Electrical power is delivered from onboard subsea power packs, and communication is conducted through Nasmux acoustic communication units and associated transducers. The acoustic technique behind the success of Nasmux is Nautronix ADS-squared signaling. This unique technology has been proven in many areas of offshore operation, including the NASBOP system for subsea isolation device control, introduced by Cameron and Nautronix in 2004. Nasmux offers bidirectional acoustic communication. Commands can be sent from the surface to the subsea electronic modules, or SEMs. A variety of information can be sent from the SEMs to the surface several times per second. Regular monitoring information, such as valve states and analog readings, form the bulk of the transmissions from subsea to surface. The operator can always command a request for specific information as necessary. Taking an individual valve actuation as an example, an incoming command is received and processed by the acoustic communication unit and passed to the SEM. The SEM in turn commands the appropriate solenoid driver module, which drives a pilot valve. The resulting valve actuation causes fluid to stop flowing through this section of the BOP. The change of state of this valve is reported acoustically, as are any analog values affected by this change, for example pressure, temperature, and flow rate. Emergency disconnect sequences are triggered by operators in the usual manner and processed by the SEMs. This example illustrates how full control over the BOP is achieved. With this revolutionary system, operations benefit from increased safety through a reduction of moon pool activity, elimination of riser recovery and rerun operations caused by umbilical damage, the removal of large reelers on deck, optimizing deck space and offering the potential to use smaller vessels, and unprecedented portability for a MUX control system. Nasmux addresses the safety and reliability issues associated with the umbilicals used for traditional BOP operations. With Nautronix robust ADS-squared signaling technology, the future of BOP communication lies with acoustics.